you, Ruth. So I want to talk to you briefly about what is the stormwater problem. So how did this idea of rain gardens even come about? What were we actually trying to, what solutions were we trying to meet for the problem? And so we're going to start by talking about what was that problem. If rain gardens are a solution, what was the problem that they're a solution to? And the first problem that we have is this idea of urbanization. What urbanization does is it impacts the hydrologic regime. So essentially how water behaves when it starts as rainfall, and where are the different places that it goes after it falls down and hits the ground. So before, when it was primarily undeveloped area, so think about the great open plains before we built any houses or roadways or anything, most of the water that came and hit the ground from rainfall either went down into the groundwater system or was taken up by the plants and evaporated back out into the atmosphere. That's what about 90% of the water did. Only a very small portion of that actually became what we would call runoff. And that would only be in those larger events that occur throughout the year. However, as we've developed, as we've gone in and maybe we had someone come put a house in, to maybe then a small community developed, to after that you get into these large metro urban areas like what you see down in Denver or in this downtown Greeley area, where you have largely impervious surfaces. So an impervious surface is a surface that does not let water pass through it. We're going to be talking about a lot of things about impervious surfaces. So that's one thing to make sure that you understand. An impervious surface is a surface that doesn't let water pass through it. Those are things like concrete, asphalt, rooftop shingles. All of those things do not let water pass through it, so water's going to hit it, and then it's going to become runoff. As we've developed more and more impervious surfaces in our communities, what's resulted from that has been we've changed the water balance. So now when a drop of rain hits the ground, very little of it is able to actually interact with the groundwater surface. So it's not able to get into the shallow aquifers. It's not able to get into those deep aquifers because there's that impervious surface. There's that cap there that prevents it from interacting. So what that results in is you have more water now that's going to actually become runoff. And what that more water does is the first thing is it increases our flooding. So we have a lot more water to deal with. The volume of water that we have to deal with in an urban environment is much more than what we had to deal with in the natural environment beforehand. In the most severe cases, you get what we had back in 2013 up along the foothills, over in Boulder and Longmont and some of those areas where you had bridges wash out. You had roadways that were no longer operable. That's one of the impacts of urbanization and urban flooding. The other one is just nuisance flooding. You may notice more and more regularly that you're not able to drive where you want. Your favorite intersection of how you walk to the grocery store, there's now a giant puddle of water there. So every time you get those small rains, you can't go out of your house without getting your feet wet. Between the very minor nuisance floodings to the major floodings, what we're noticing is that there's just more water that's present in our urban systems than what was there naturally. The second problem that we have is not only is there more water, but that water has higher energy, or it's at a greater flow rate. It's hitting a rooftop, and then it's going down to a concrete, then it's coming from that concrete down into your concrete pipe, which is our collection system. It's running down that pipe, maybe eventually coming to a steel pipe. But anyways, it's hitting these impervious surfaces that allows water to move very quickly. Water going over natural land cover, the natural ground, moves fairly slowly. It's not able to accumulate a lot of energy. It's able to disperse itself. It gets caught up in the brush and the undergrowth that happens there. The rock or the dirt itself provides just friction to slow that water back down. You don't get that when you have these concrete surfaces, when you have this large amount of asphalt. So what ends up happening is that water has more energy. And so when it eventually does make it into our streams, our natural waterways, our lakes, ponds, whatever, it starts to erode. It starts to dig out those sides, remove the earth, remove that dirt. And so instead of having nice, beautiful channels going through your cities that people enjoy that are those natural amenities, you start having channels that look like the picture there, where you have dirt that's being dug out from the sides because you have all this energy of water just cutting into those sides of your channels. But there's a third problem as well. Not only is there more water, not only does it have higher energy causing erosion, but it's also dirtier water. So urban runoff has a lot of pollutants inside of it. You have things like oils from our vehicles. You have trace amounts of metals, which if you think about just what your car maybe deposits, isn't very much. But when you start talking about thousands of cars to millions of cars going across some of these areas, all of those little deposits of metals when you press on your brakes, when you have the sand that comes and blows against your car out here on the plains, and it chips off just that little bit of paint. All those chemicals eventually make their way into our water bodies. And it can be harmful to fish, and eventually it can even be harmful to the point where we can't use our water bodies for their intended purpose. The best case scenario is that you just can't use them for recreation anymore. Some of the worst case scenarios is we in Colorado, where we recognize that we have very limited amount of water, start polluting some of our primary drinking sources. So when we can no longer use some of our reservoirs, some of those water supplies that we count on are no longer available because we've polluted them to such extent from our urban runoff. So those are the problems. We have more water than we know what to do with. It's coming in faster with more energy that can damage things. And it's also very gross. It's not good water. You have pet waste, our human waste, our vehicle waste. You have nutrients that are in there from our leaf litters. All of this is coming together and getting into our receiving water bodies. So what could you do as a private citizen? At a local level, municipal level, the city has what we call a stormwater permit, where they're required to install stormwater infrastructure, or not required to install, but make sure that it is installed by new development that exceeds an acre. So some of that new stuff we're handling at a large scale. However, what could a private owner do? Private owners, they have limited budgets. I'm sure you're not budgeting away thousands of dollars every year to handle the stormwater off of your property, right? That's not what we want to be talking about here. You also have limited space. You can't make a huge detention pond in your front yard, right? There's safety concerns with that. There's just aesthetic appeals to that. You don't want a giant pond in your front yard. Then also there's a limited stormwater experience. Before I started coming to school for this purpose, and even now when I still talk to friends, family, I'm like, oh, I research stormwater. The most common response I get is, oh, I guess that's a thing, huh? Most people don't realize that's something you have to think about. Lo and behold, that's what my entire career is talking about stormwater. So it's safe to say that the average citizen is not just going to know the proper steps for stormwater design to turn their house into a fully functioning stormwater treatment process. However, what we have found is that there is a very simple technology that is available, and that's rain gardens. Rain gardens are so cool because they don't require a whole lot of technical experience. They require you to know a few key things, which is what we're going to talk about here today, and then just to have the space and the desire to want to have a native species rain garden bed planted in your lawn. What we talked about, there's plenty of benefits to that. If you on your own property are noticing large amounts of flooding, maybe you have water that's being directed to a certain location and you just don't like it. You don't like the flooding that's happening there. Maybe you have water that's starting to run back towards your house and you don't want that water accruing at your foundation because water and foundations to houses do not mix very well. Or maybe it's that you do just want to do your part with stormwater management. You want to help reduce the capacity of the system. Maybe you notice that a street flooding is happening and potentially the City of Greeley eventually needs to address this, so they make an incentive program to say, if you can manage the water at your house, we may incentivize that. Whatever ends up being the case, rain gardens end up being a pretty cheap and a very effective solution to, one, have a zero-scape type methodology for your watering plan at your lawn. So it doesn't require a whole lot of extra water aside from the first establishing year. So when you have to establish the vegetation, that takes a little extra water. But after that, the goal of these systems is that they are completely self-sufficient. You're not having to irrigate, so you can turn part of your landscape into this very attractive feature that requires low irrigation, can help save you money as a homeowner, as well as helps treat the stormwater problem at the city. So it's one of those things where if everyone does kind of a little piece, it can have a very big impact overall in different watersheds. So these are just a couple examples of some rain gardens, varying in site complexity. The one at the top left, that's one that's actually developed over at the CDOT facility down in Denver. So this is probably the most complex of design that you could have as far as rain gardens go. This isn't the kind of rain gardens we're going to be talking about today. There's a lot of engineering that goes into it. This is something that they're having to do to meet their permit standards. So if this isn't designed correctly, if it doesn't operate correctly, you have the state health department that can get involved and start causing penalties. You have EPA that could potentially get involved, start causing fines. So the one on the top left, that's designed to a very high standard. It takes a lot of complex knowledge, technical knowledge, to be able to install that. There's a lot of concrete work there that you can see. And overall, this is one that's just being established. It was just done last year. So this is a picture right after, so you can see all the plant plugs were just planted. They haven't grown up at all. That's a very complex site. So that's the kind of far end of the spectrum, that if you really want to get into that, you can come talk to me afterwards and we can sit down and go through all those equations to make it permit compliant and everything. However, that's not what the typical resident is going to want to do. That's kind of an overkill. What we're talking about, the other end of the spectrum, could be that picture there in the center. This is one that I saw just in my neighborhood, where it's literally just some plants that this resident planted. They put these bricks to help cause the water to pond there, and then all they did was they directed their downspout to go to those plants. Simple, right? These are one of those things that anybody can do if you have the lawn space to do that, and if you have that desire to want to have an attractive feature here. Once again, this was taken a month ago, 2 months ago, so as before things are starting to bloom. I'm probably going to go back there here in a couple weeks now that we're getting into full springtime to see what do these kind of simple rain gardens look like. But now we have some of the other rain gardens that are present in this picture. At the top picture in the middle, that's a pretty simple one as well. There's just a lot of plant plugs in there. It's just meant to collect the rainfall. This is actually a parking lot. So there's a parking lot all around it, and it's all sloped so that the water's going to run directly into that system there. So as it rains and the parking lot has water, before all of that extra water could potentially overwhelm our stormwater systems. It could cause this minor nuisance flooding, and it could be a real issue for the residents of this area. But now what it's actually doing is being a water source to provide irrigation to some plants there in the center. So it's breaking up the parking lot so it's not just a big hunk of pavement, while not having to run irrigation lines, making sure that you're spending a lot of money on irrigation each year. The other examples that we have, there's one that shows that even here in Colorado, you can get some nice vegetation to grow. We have a lot of pretty cool native species in Colorado. It's not all just prairie grass. We do have some native flowers that you can grow, particularly at this altitude. We're kind of right at the cusp where some of the higher altitude plants can't survive too much, but if you treat them well, they actually can still survive. But we are at the climate where they're not going to get frozen out super early like they do up in the mountains. So it's kind of an interesting little kind of balance that we've struck here in this front range to the eastern plains area. So you can have a rain garden that looks very nice, that you can have very full, mature, flowered plants growing. Alternatively, you have the one to the bottom left now. And the reason I have this slide or that picture in there is to show that you can have multiple sources contributing to your rain garden. So in that picture, there's actually a downspout that's coming down. So it's some of the rooftop runoff that's coming from as water falls on the roof, goes to the gutter, goes down the downspout. Some of that water is directed into the rain garden, but also you could see the pavement is causing water to run off the pavement, run off their driveway, and that's also going to go into the rain garden. So you can treat multiple sources of water. It doesn't have to just be rooftop runoff. There is a way that if you have the grading, you could actually get your driveway to help contribute to the irrigation regime that you need here. The biggest lesson to remember about designing rain gardens is water is going to flow downhill. If you can start with that level, that is the first rule of stormwater management. Water will flow downhill. Gravity does, in fact, win. If you understand that, where you place your rain garden starts to become pretty simple. You just start looking at where are the low spots? How can I get the water that's going to be to make sure that the surface where I'm collecting the water is above where my rain garden is going to eventually be located. So what is the rain garden? The first thing, it's a landscaped area. It's a landscaped area that's not just there to be landscaping that we're going to irrigate, but it's actually designed to capture stormwater runoff. So the whole point of this landscaped area is to capture that runoff, allow it to pond, and then what it's going to actually do is also reduce our stormwater pollution. So after it captures that stormwater runoff, all of those harmful things that if they just go directly to our receiving water bodies could potentially pollute our lakes, reservoirs, streams, are going to get trapped now in this media. And thankfully, they're at such low concentrations at an individual roof level that you don't really have to worry about them. That's the beautiful thing. If we have these distributed systems where everyone is just taking a little bit, it's not harmful. But it's when we collect all of it together and then put it in one location that they start to get to these harmful levels. So worst case scenario, you have the dirtiest driveway in Colorado. You may have to replace your media once every 20 years. Like, that's what we're talking about here. We're talking about very low maintenance for the benefit that you're providing and reducing some of that stormwater pollutants. The Stormwater Center has a manual. That's what the next few steps we're going to be talking about. They have a printable manual up on our website, literally called Building a Rain Garden in Colorado. So it's about a 10 to 13 page manual. It's going to have all the detailed instructions of what we're going to talk about now. And so that's available for you to go download, print out, whatever you'd like to do. As we get into more of this section of talking about how do you actually install the rain garden, how do you plan it out, how do you design it, how do you construct it, feel free to ask questions at this point, because this is the part where this is why you guys came, right? It's to learn how to install a rain garden. So if you have any questions as I'm going through these next couple slides, the rest of the presentation, feel free to stop, raise your hand. Let's just get those addressed. I like having more interactive. Don't feel like you're breaking my rhythm. I don't have a whole lot of rhythm to begin with, so I'm okay with you interrupting at any time. So let's go ahead and get started. So the first question that I always get when people ask, well, I want to build a rain garden, how do I do it? The first step is location, right? Location, 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 just like buying a house. The main things to consider when you want to place a rain garden is the first, avoid your utilities. So call 811, call before you dig. That still applies for a rain garden. You may think, oh, I'm only digging 4 inches, 6 inches. I'll be fine. Particularly if you're going to be using some of the mechanical tools that we're talking about here, or some of the power tools of maybe a tiller or something to help break up that dirt, call before you dig. You don't want to run into a utility line. You definitely don't want to run into your utility line. You also wouldn't want to tear up your sprinkling system or anything like that. So just be aware of where your underground utilities are, where any underground pipes may be located. That's the first step of looking at where to place your rain garden. The second step is thinking about you want it away from your building. You don't want your rain garden right up next to your house foundation, because once again, we're going to be directing a lot of water to this site. So if we're directing water to this location, we don't want it, where the water goes after it gets into our rain garden is it goes into our groundwater. If the groundwater is right next to your building foundation, you could potentially really cause damage to your building foundation. So keep it at least 10 feet away from buildings and foundations. That's the second step. So look for utilities and keep it about 10 feet away, at least 10 feet away. So once you're 10 feet away, it doesn't matter anymore. You're far enough away from your building that you'll be okay. Next is we're trying to grow plants here. So putting them in that nice shady spot in your backyard is not a good idea. It's just because they're native species doesn't mean they can grow without sun. They still need that sunshine. They still need our nice Colorado sunny day. regime of sun regime. I don't think that's the right word for it, but exposure, there we go. So making sure that you do have that full, at the minimum, a partial presence of sunlight available to your site. Don't stick them in that poorly lit corner and say, well, my grass isn't growing there, so now I'm going to put a rain garden there. If the grass isn't growing there because of sunlight, the rain garden's also not going to grow there because of sunlight. If the grass isn't growing because your irrigation system doesn't hit that corner, but now you're going to direct runoff there, now you're in business. That's a great spot to put a rain garden where you don't have to kill your own grass or anything, but can utilize those kind of spots. The next step is you want to make sure your rain garden is being placed where there's stormwater runoff available. So that means next to downspouts of your roof, or where you're at least comfortable that you can get the water from the downspout to your rain garden. So it doesn't need to be next to the downspout, but make sure that if you're going to be digging a pipe or digging a trench, digging a channel, that you're comfortable with how much you're going to have to dig to get there. If you put your rain garden 50 feet away, know that you're digging a 50-foot channel to go and direct that water over there. Or if you're going to have a pipe that's going to convey that water, you're going to have to dig up the trench to lay that pipe. So just be aware, the further away from your source you are, the more you're going to have to put a little manual labor into making that happen. The other thing about stormwater runoff is remembering that first rule of stormwater. Stormwater flows downhill. So not only do you have to see where are my downspouts, but make sure that you're not going to try to have the water come down the downspout and then up 2 feet to your rain garden. It's not going to work that way. Water's going to you could technically install a pump and things, and then you start getting into water right law, and it starts getting real iffy. These passive systems are okay in Colorado water rights law, as long as you're not storing the water for over 72 hours. So that's one of the good things about rainwater, is you're not breaking the law. It's not like the rain barrel law that was in effect that is no longer in effect, so that's good. But you're not breaking Colorado water law if you're using it for natural processes passively. So you're not putting that pump, that sump, and storing the water for an extended period of time and then pumping it onto your grass to help water your lawn. When you do that, now you're breaking water law because you're using your stormwater for a beneficial use. You're actively using that stormwater for a beneficial use. With these rain gardens, it's all a passive system. You're not in control. So therefore, you're not truly using the water. You're just directing it so that it can infiltrate like it used to do before we built that house there. So that stormwater runoff available, that's a pretty packed point of making sure water can get there, making sure you're near a stormwater source, either the driveway, the downspout, whatever you're gonna be collecting. I've heard of people trying to do curb cuts. Don't do that. Do not cut the curb on the front of your house, okay? The city put those in. They have safety reasons. They have insurance purposes. There's a whole lot of litigation and lawyer stuff that goes into having curbs. If you go and start cutting the curb yourself, that's a very dangerous thing to do. Please do not. We do not want to encourage you to cut the curb. But being able to direct that water from your downspouts, from your own driveway, that's a very good place to start putting these rain gardens when you're looking at your lawn. You would like a place that's relatively flat sloped. Again, this is not a deal breaker. If your location is going to be at an angle, what that means is you're going to have to dig it out to make your rain garden flat. So the surface of your rain garden needs to be flat. So just keep that in mind. The steeper the angle, the more work you're going to have to do to make sure that your final elevations of your rain garden are relatively flat. If they're sloped, then water's not going to be able to infiltrate correctly. So the parts that's on the higher slope is not going to receive as much water as the parts on the lower slope. So you're just going to have uneven watering when you start looking at a rain garden constructed on a slope. And then finally, you want to avoid the septic tank or leach field. So don't put these systems in right next to your septic tank. You don't want to be filling up your septic tank with, or your leach field with, your own stormwater runoff. So the question was, how do you manage slope? What does that really mean, managing slope? It doesn't seem capable to be able to manage the slope. What we mean by slope is not like a hillside. So 1 to 2% slope is okay because we're going to be ponding this water up a couple inches. So the natural slope that's probably present at your lot is usually okay, and there's ways that we can actually create berms. And when you start digging out depths, what the dirt that you dig from one side of your slope, you're going to move over to the other side of the slope, so you can kind of flatten that area out naturally yourself. But we're not talking about, it has to be like you have to get a level out there and make sure it's perfectly flat. It's not to that degree. It's just that you want to try to avoid, you don't want it there to be a 4-inch slope when your depth's only 4 inches of your rain garden, because water's going to just be spilling out of there. It's not going to be sized appropriately. I would try to avoid easements. The issue, if you go to a place where water is going to be directed from another site to your site, without understanding what that contributing area looks like, you may not be able to size your rain garden appropriately. And so it may start getting a lot more water than it's supposed to, and you're going to start washing your plants out. So now we're going to get into sizing your rain garden. How do you size it? We try to keep this as non-technical as we can, but there's 2 parameters that you're going to be looking at for sizing. The first is depth, and the second is area. Your depth is dependent on this drain time idea. So we don't want water that's going to be ponded there for a long period of time. From a water law perspective, that time is 72 hours. From a healthy vegetation perspective, we want to try to keep that to about 24. We don't want a lot of water saturating this area for more than 24 hours. If so, that could cause your plants to die because of getting waterlogged. The other thing that we have, so once you understand how much depth your site could accommodate, now you can look at what is the surface area that we need. And this is going to be based off of a quick volume estimation of how much volume can you expect to be received by this rain garden for the common storm in Colorado. So we'll walk you through that design as well. So there's depth and area. So for determining depth, what you do is you want to dig a hole in your yard where you're planning on putting this rain garden. So once you have your location picked out, you dig a hole about the shape of a coffee can. And then we want you to fill that hole with water and measure the initial depth. So you dig a little hole that looks pretty much like a coffee can, fill that hole up with water, and then measure the depth. And then what we want you to do is, after 4 hours, measure the change in water level. So how much water went into the ground over the course of 4 hours. What that can let you do is now you can calculate how much depth are you going to need in order to drain that in 24 hours. So how much depth could this accommodate in 24 hours? So what we recommend is not going much beyond 12 inches, period, across the board. So if you need more than 12 inches of depth, that could be an issue from a safety perspective, from this ponding, clogging. There's a whole bevy of issues that start arising if you go greater than 12 inches in your rain garden depth. So the idea behind this is we're seeing how quickly does water go down. So if you take, so say for instance, you measure, so you dug your coffee can size hole, so it's about a 5-6 inch hole, and you found that 2 inches went down over the course of that 24 hours, or over the course of that 4 hours. So you went out, you filled up your hole, you went out 4 hours later, the hole is down 2 inches. That probably means, one, that your lawn is primarily clay, so you have some pretty clay material there. But then what you do is you divide that 2 inches by 4 hours. So what that means is you have a 1/2 inch per hour. So now what you could do, so the whole idea of this is we have your lawn, the soils in your yard can handle about a 1/2 inch every single hour. So over the course of 24 hours, that means that it can handle 12 inches, right? So if you have a 1/2 inch per hour times 24, that's 12. So that's how deep your rain garden can be. So this is the change in water level divided by 4. So this is what this table represents, is what is that change in water level over 4 hours? That's a misnomer. I should not have labeled it that. I'll make that change before I give it to Ruth to post online. We're not going to do, that was poor labeling on my part. That is the overall change in water level that occurs over that 4 hours. So you could see, if it's 2 inches per hour, you could have a 12-inch rain garden. If it's less than 2 inches per hour, then you have to accommodate less depths. So if you go out there and notice there's only a ½ inch, so after 4 hours, you dug your hole, filled it up with water, and after 4 hours, it only dropped a ½ inch. That means that you can only have a 3-inch deep rain garden. So if you try to make it more than 3 inches, you're going to have water that's going to be ponded up there for longer than 24 hours. Once again, it could potentially lead to harmful vegetation growth. In winter, so the question was, how do you accommodate winter? A winter runoff event will not provide enough rainfall that would overcome the system that we're designing here. So that's the general answer to your question is, winter snow runoff usually melts slow enough that our systems can handle it just fine. When you start talking about having a lot of area directed from neighbors' yards, you do need to understand how much are they putting there. But the goal here is the depth is not dependent on how much water you have. The depth is dependent on what is the capacity of your system to be able to hold. So if you have good soils, you can have a deep rain garden. If you don't have good soils, then you have to have a shallower rain garden, just because it can't handle that much depth. So this is what we call an infiltration test. That's all this is showing is and this also should note is it's the maximum depth. So it's the depth we don't recommend you exceed. It does not mean that you have to have this depth. So maybe you have more of an area that you want to supply. Then we'll talk about how you can calculate that as well, because that's a second parameter. But are there any other questions of depth? So 2 things to note. 1, this divide by 4 is not divide by 4, it's over that 4 hours. I think that's what the divide by is supposed to mean, like over 4 hours, but that was poorly labeled. So I'll go and check and make sure the manual has it correctly as well. So that's the first thing. And the second thing is that this is the maximum depths. So it's not what your depth should be, it's what is the maximum depth allowed. And so why do we have a maximum depth? So we don't drown the plants. So calculating the surface area of a rain garden. This is the second big parameter, and this is where you take into account how much of that impervious area that we were talking about earlier, how much of that are you going to have contributing to the rain garden? So if you have a lot of impervious area, so that means a lot of rooftop or a lot of driveway or a lot of your neighbor's rooftop, whatever that may be, coming to this area, you need to have a general idea of how much of that area is it? How big is that area? How many square feet is that area going to be? So there's a few different ways that you can do this. You can do a coarse measurement. So notice that you don't need the sloped area of your roof. So your general rooftop square, maybe you have an estimate from someone who came and shingled your roof, and they gave you how much square foot of roof you have. That square foot of roof usually includes pitch and angles. That's not the area that you need. You need to know how much of the flat area. Because, right, the rainfall is only going to fall flat. It doesn't fall along the whole surface of your roof. So you can just coarsely measure that. You can just step it off and say, well, I know this part of my roof, usually a good rule of thumb is go the halfway point in your downspouts. So find your 2 downspouts and go halfway in between them and know that that's the breaking point. So half of your roof is probably going to go to the next downspout. The other half is going to go to your first downspout. So that's if you have downspouts along a long part of so maybe at the front of your house and back of your house, the pitch is all coming towards that gutter. You could generally assume, so looking at your house, you notice that actually there's a breaking point here because there's this gutter. Usually we try to build our houses flat. So because we try to build our houses flat, that break point is typically right there in the center. So that's the first step, is you find halfway points between all your downspouts, and then you just walk that off. And so you can say, okay, this is about my square footage that's going to be contributing there. Some of the things that you have to look for are peaks. So finding those peaks in your roof. Where is it located? What water? Sometimes what you may find is you're going to have actually a lot of water coming to this rain garden or coming to that downspout because your whole roof is slanted to this side. So it's just looking at your roof, finding what's the contributing area. Similar things for driveways. If you're going to utilize some of your driveway runoff, you just want to step off that driveway and how much of it is actually going to be able to make it into your rain garden. So once you find what all that impervious area is going to be, what you then do is you just multiply the area. You have that area, that's square feet. Then you multiply it by 0.5 inches. So the reason why we do it by 0.5 inches is because there's a whole lot of stormwater theory and science that was done to determine that 80% of the storms in Colorado are a half inch or below. So what that means is 80% of the time, the water's not going to exceed a half inch. 20% of the time, it's going to exceed a half inch in an average annual year. So from the stormwater, what we notice is that if you try to make your rain garden bigger, it's not as much value, so it's diminishing return. So up to the 80% point, you're getting a lot of bang for your buck. If you try to make it to account for more water, it's not as cost beneficial anymore. So that's essentially the thought behind why we have a half inch. That's the value that we use for a lot of our stormwater management here in Colorado. So that's what we recommend that you guys use. Most people don't understand where that half inch comes from. We just tell them multiply it by a half inch. Now you kind of know where it comes from. It came from someone who did a study on Colorado precipitation and then did a bunch of cost analysis and determined that after a half inch, it doesn't make financial sense to continue to treat. So when you have a square foot and an inch, and then you divide it by the depth of water you want your rain garden to be, that's also an inch, inches measurement, what you're left with is the square foot of your rain garden, how much square foot that should be. Alternatively, maybe you know what square footage you want your rain garden to be. So what you can do is you can take this square foot inch number, so the square foot of impervious area times a half inch, and you divide that by what area you want it to be. So you know that you want 20 acres, or not 20 acres, gosh, that's a huge, 20 square foot rain garden. You'd like 20 acres, yeah. Now you're talking about a regional detention facility. You are the one that could put the pit in their yard and be just fine. So you may have the square footage. So you take that square foot inch number and you divide by your square footage now you get what the depth of your rain garden should be. Once you understand what the depth of your rain garden should be, you go back and make sure it isn't bigger than that maximum depth that your soil can handle. And as long as the number you calculate when you take the area times a half inch divided by the area of your rain garden, as long as that's not bigger than that maximum depth you calculated, you're good. Don't have to worry anymore. You're all within regulations, or within an acceptable design that's not going to kill the vegetation because you're drowning them, and will actually provide an adequate water supply as well. So that's the other thing, is you don't want to have this huge rain garden that you're trying to support with too little runoff. So you want to make sure that you have that balance, that you have a rain garden that's going to receive an adequate amount of runoff, as well as having a rain garden that's not going to drown the plants. So if you follow these steps, you should be able to get there. So once you have those measures, so that's your design. The area and the depth gives you your design guidelines. So you know how many square foot you need and what depth are you going to want those berms to be built up to. Now you get to the fun part. Now you get to determine your layout. The good thing about rain gardens is they can be just about any layout you want. You can make it as crazy, as uniform as you want it. This is one reason why they're a pretty nice feature for residential landscapers, because maybe you have that curve, your sidewalk goes around your driveway and then up to your house, and there's that weird curve that you don't know what to do with. Well, you could potentially make that curve into a rain garden. You usually have a gutter or a downspout right there too, so it usually ends up working pretty well. So it doesn't have to be a square, it doesn't have to be a circle. You can make it any size you want it to be and just do some rough approximations to make sure your square footage is about what you calculated it needed to be from the previous steps. So that's the goal. So then you still have to factor in the other location elements. So you want to make sure that you're not right next to your house. You want to be away from your foundation. You want to make sure that you have the proper depth so that it can pond the depth, because now you know how much depth you're going to need. So you want to make sure that it can actually accommodate that much depth, that you have that elevation difference to be able to pond that much, and that it's a relatively flat surface. Once again, less than that probably 2% slope. You want it relatively flat, but it doesn't need to be put a level on it flat. So once you have that, you can get some materials. So you have your location picked out. Now it's about what materials do you want to use. We recommend putting about a half cubic yard per 100 square foot of compost. We're going to be mixing that into the native soils. So it's not going to be just a general, you're not just going to scatter that on top, but it actually needs to be mixed into the soil so that your root systems of your plants can pull up that compost, that nutrients, those organics that the plants need in that compost. And once again, that's about a half cubic yard per 100 square foot. Some 2 to 4 inch cobbles. These we're going to use for what we call energy dissipation. So when you have that water entering your rain garden, we don't want to let it dig out your rain garden, because then it's going to dig out your plants. So I'm not sure if you did this as a kid, but with the hose, how you can make holes in the ground with the hose. This is essentially the same idea, just a little bit bigger, except now instead of a hose, you have a gutter or downspout. Instead of you holding it, you have a rooftop that's directing that down. So the same idea still holds. If you have a lot of energy in that water and it hits that dirt, it's going to start digging a hole there. However, you put a couple big rocks there, well, not even big, 2 to 4 inch rocks, you can help dissipate some of that energy, make sure that you're protecting your rain garden. And that you're just going to need enough to put around the mouth of your inlet. So wherever the water's coming in, you're going to want some cobbles there. So that's going to be site specific. If you have a lot of inlet points, maybe you have multiple gutters or a huge driveway that's feeding into this, you're going to want some of that cobble all around the place where water's going to enter, just about 2-3 inches back. Then you're going to want a 4-inch drainage pipe or downspout extension, because once again, we're trying to get away from the house. So you don't want it to just collect right there at the base of your house. You're going to need something to get it away from the house. The other alternative is you can dig your own channel and line and cobble that. That's one potential solution. But if you don't want to dig a channel, then you're going to need that drainage pipe. Then also mulch. This is personal preference. We recommend the mulch because it helps provide some of that cover, helps let your vegetation grow, helps retain some of that moisture. So mulch does have some good benefits. Something to note is you don't want to use those large bulk bark mulch. You don't want the bark, because those are very low density. They float very easily. Once again, we're designing this so that 80% of the storms are not going to exceed the volume of our rain garden. 20% of the time, it's going to exceed the rain garden. For that 20% of the time, if you have a lot of that really floatable mulch, it's going to wash out, and you're going to be replacing a lot of mulch. It's going to make you very upset. Particularly, I've found this is when you have it right next to where you mow your lawn. You have all that floating mulch washing out into your lawn, and then you spend the next day raking up the mulch and putting it back, and you're very upset. But at least your rain garden's full, and you're watering that. So that's nice. The other thing to note here is you cannot use a weed barrier. So do not put a weed barrier underneath your rain garden. The whole point of the rain garden is to let the water come in and soak into the groundwater system. If there's a weed barrier there, it doesn't do it. So now all you're going to do is drown your root structure. So the plant may not drown, but your roots are going to drown. So your plant's still going to die. The unfortunate thing about this, so you don't get weed barrier. You can't spray these things with chemicals. So that means you're going to have to buck up for a summer of weeding. That is the unfortunate thing about rain gardens with native species, is they do require a good amount of weeding each year. However, you're not watering them, you're not mowing them, but you do have to make sure you go out and weed them. And the more periodically you do that, the easier it's going to be to maintain it. But don't use chemicals and don't try to put down weed barrier. Both of those are solutions that will directly undermine the whole system you're trying to build. And then you think, well, I'm just gonna spray these a couple spots of weeds. Remember, water's gonna come in and fill up that whole area. So the chemical that you put in one place isn't gonna stay in that one place. It's going to get washed over to all your plants. You will kill your plants. So you can't use chemical, can't use a weed barrier. So just good old American grit. It's gonna have to get in there and keep these things from getting weeded out. All right, some tools. You have your typical gardening tools. Spray paint, I guess that's not a typical gardening tool. That's for delineating what your rain garden boundary is gonna be. Some of the optional tools that you can have is that garden tiller. Once again, that's gonna really help to mix in that compost. If you're not using that garden tiller, again, that's just good old muscle and shovels at that point to get this thing dug up, try to mix some of that compost in. Because you do want to mix that compost into that soil so you can get some nice, deep, good roots growing with your vegetation. A mattock, I didn't know what that was until I started teaching this course, but now I know. It's that giant, cool, it has it's almost like a pickaxe with that nice, good spade at the end, and it can take out some roots. So if you have a lot of roots in your area, make sure they're a root, not a water line, not one of your sprinkler systems. That's the danger we run into if someone just goes and then hacks something and water's everywhere. And then trencher, once again, this is gonna be useful if you are trying to have a pipe that's going to transport that water over to your system. So now getting into the construction process. So you've done all the planning, the design work, you've collected all your tools, your materials, now you're ready to go out and get some stuff done. The first step is to mark an outline of the rain garden. So that's what the spray paint's for. Make sure you're avoiding the utilities, can't stress this enough, 811, call before you dig. You don't wanna, particularly if you're trying to do one of those 12-inch ones, you don't wanna run into any kind of utility lines. The next step is you wanna dig out the rain garden to the calculated depth. So we calculated how much depth you wanted to capture here. If you do too much depth, all that's gonna mean is in those bigger storms, it's gonna be filled up for too long. Now that's not necessarily gonna be a deal breaker, right? So it's not like you have to be out there with a ruler and measuring everything all around. We're not getting that scientific here. But just know if you have a little bit more depth than what you planned, you're gonna potentially start exceeding that 24-inch or 24-hour rule. You're not into any water rights issue, and it's something that should only happen a few times a year, but it is something that might happen, so just be aware of that. You do want to try to, once again, make the bottom as flat as possible. I do think this person's going a little overkill with it, with the level and everything out there, but you can make these things really nice. A lot of the dirt that you're going to be digging out to get to your appropriate depth, you can use as a berm, so then you only have to dig half as deep, right? If you can build up a wall as well as make the bottom go down a little bit more. Dig out that bottom. You don't have to dig as far. So that's all things that could help be nice. So the water that's going into the rain, so the question was, there's a picture that's the rain garden's very close to a tree, and does that matter? The answer is no, because the water that we're designing for is not what's gonna fall on the rain garden itself, but it's what's coming off the roof. The only time that it matters is if the tree is constantly keeping it in shade so that the plants couldn't grow and be healthy. But as long as it's not completely blocking the sun throughout the whole day, then we're not too worried about trees. It's gonna make digging a little bit more challenging. You're not gonna be able to dig as deep without starting to get into some of those roots. But so the next step is to apply the compost and mix into those 8 to 12 inches into the soil. So once again, if you have a garden tiller, that's gonna be very easy. If you don't, it's gonna be very hard. But either way, you need to get some of that compost down throughout that column so that the whole root structure can have some of those organics to be able to grow nice and healthy. The next step is directing the runoff to the rain garden. Once again, there's 3 different options for doing this. You could just extend your downspouts. Once again, keeping in mind elevation, that water's gonna flow downhill. So if you start having these big sinks. So maybe you built up your berm walls real high because you didn't want to dig very far. And then your downspout's pretty low, and you're going to try to start pushing that water uphill to get over your berm. It's not going to do that. Water has to flow downhill. So just keep all those things in mind. You may need to bury a drainage pipe. So you can bury that drainage pipe so it discharges into your rain garden. So it can discharge into the bottom of the rain garden. That's fine. The water doesn't have to enter from the top. It can enter at the bottom, but just know water is going to flow downhill. So if your pipe's trying to push the water uphill, that's a problem. You can have that slanted pipe coming and entering into the bottom of the rain garden. But just know that that bottom of the pipe is going to be filled with water. And yeah, there's that potential there of, once again, trying to force water uphill. It doesn't like that. The final solution here is to build a drainage swale. What we notice with drainage swales is those you are going to want to use weed blanket on. You are going to want to try to keep water from infiltrating along your swale because we don't want the water to get into the groundwater along the swale. We want it to get into the groundwater at a rain garden. So you do want to try to barrier that. You want to try to make sure that water isn't able to infiltrate where we don't want it to. We want it to make it to our rain garden. If it's a short little swale, you're not too worried about that. However, if it is a longer swale, just note that you may start incurring some of those losses. You may not have enough water to irrigate the size of rain garden that you're planning. So that's just something to keep in mind. All right, steps 5 and 6. This is almost the end. As we mentioned, you're going to want some of those 2 to 4 inch erosion stones or cobblestones. Those are for energy dissipation. So you want to put those right at the base of where water's coming in, particularly if you're dropping the water at the top of your berm. So it's going to free fall a couple inches. You want to make sure there's a little bit of rock underneath of that so that way it's not going to dig out and erode your rain garden. And then what you want to do, finish your rain garden, you want to plant either plotted plants or you're going to be mixing seed at this season. You're at the kind of potted plant schedule. Your mixing seed's going to be a little tough. We're kind of at the end of that window, but still, I guess, kind of possible. Then you're going to want to, after you plant, plant your plants. That sounds like a weird saying, plant your plants. After you have planted your native species, you can go ahead and apply some shredded mulch. Once again, not that large bark mulch because you don't want to run that over with your lawnmower when it inevitably overflows your rain garden. The other thing to note is you're going to want to, you are going to need to water these to get them established. The native vegetation eventually will be able to be accommodated and irrigated purely by the natural regime of rainfall that we have here in Colorado. However, until it is established, it's going to need a little more watering. The other thing to note, sometimes people like to plant native grasses along these. But then what they'll do is they'll plant those native grasses, and in mid-July, they'll go and cut their native grasses down to like 2 or 3 inches because they start to get tall, little unruly. They may not like the way they look, so they'll go and they'll chop them off. If you do that, you will kill your native grasses. The way native grasses work is they get nice and tall, so that way in the heat of summer, they can protect their root structure from the sun by providing shade. It helps them retain moisture. It helps the soil stay nice and cool. So if you go and you cut them off, they no longer can do that, and so you're probably going to kill them. So if for some reason you are planting native grasses, make sure that your mowing regime isn't planning on going in there in the middle of July and cutting those down. You're going to want to keep them until it starts getting cool again in the fall. Then you can go in and mow if you need to or want to. So plant selection, if you look up Colorado State University's Extension Office, they have a great fact sheet talking all about native plant species here in Colorado. So if you aren't aware of which kinds you want, you can go onto their website or download their fact sheet, and they sort them by color, so you can pick different colors for your rain garden. Like I said, we do have some pretty cool native plants here in Colorado. Some of the cooler ones end up being a little bit more expensive. Funny how that works, but that's something you're gonna have to keep in mind. But for the most part, you can get some very nice, very colorful rain gardens that are well maintained and look really good and don't require irrigation on your part after it's been established. So once again, reduce your water demand as well as have very nice, aesthetically pleasing vegetation. That's the goal. So from a maintenance perspective, what is it going to look like? You're going to want to irrigate that first growing season, once again, just to get everything nice and established. After it's established, you should not have to irrigate. The only time you may have to irrigate is if for some reason there is that hot, dry spell where in that drought year, which is kind of funny, you're going to have to provide a little irrigation. Once again, it's not going to be like the Kentucky bluegrass irrigation. A little bit of irrigation to help sustain the plants in those hotter, drier seasons. So out in nature, usually the plants go dormant again in the hot, dry season, so they're not going to bloom and flower and look very good. But it's hot and dry, so the plants don't care. If you want them in your rain garden to still bloom and look good, you're going to need to provide a little irrigation in those really hot, dry spells. But once again, that's when you're starting to get the drought alerts, and even then, you're only watering them a little bit. You're not watering them a lot. You're not watering them like you do your grass. You're just watering them a little bit to keep them alive. This next point is very misleading. Weeding may be required as needed. Weeding will be required. You're going to be doing, that is the primary, that is going to be the primary maintenance activity that you're doing is weeding. And once again, the more often you do it, the easier it's going to be. If you let it get away from you, good luck. You're going to be digging out or pulling weeds, getting them out by the roots. Hopefully, you don't let it get out of control to where you're potentially ripping out your own native plants as well. In Colorado, sometimes the native plants look like weeds anyways, so maybe you're just able to pull that off and just say, yeah, it's all a rain garden, we're good to go. The other thing to note here is fertilizing. After you amend the soil with that compost and give it those organics, fertilizer should not be needed. And our runoff, our stormwater, has a lot of nitrogen and phosphorus in it just all on its own. So that's one of the really good things about stormwater is it's really good for watering plants. And that's what's neat about our rain barrel law, is if you're using that 110 gallons to provide lawn irrigation, you're probably giving your lawn a lot more nutrients than it originally thought it was, or expected from just our normal tap water. So that's one thing to know, is fertilizing should not be necessary in the rain gardens. Stormwater all on its own has plenty of nutrients. It's going to keep those things well fertilized. The other thing, once again, if you have a crazy dirty parking lot or something, if you're just directing roof runoff, you shouldn't be worried about sediment accumulation. It's only if you're doing driveways, parking lots, roadways, something where you're getting a lot of vehicle traffic with a lot of mud, then you're potentially looking at sediment accumulation, dirt accumulation in your rain garden that you may have to remove periodically. Once again, even then, we're talking 10, 20 years. If it's happening every year, then text me or call the Stormwater Center. I want to come out and see this thing, like what is causing. I've never, even in our municipal facilities that are receiving direct runoff from highways don't get that dirty, so we're hoping the residential lots are going to stay nice and clean. All right, well, thank you very much.